Hi there, and welcome everyone. Thanks for joining us for the latest webinar, Launch and Scale Your Social Game in the Cloud. So as usual, we're going to start off with just a few polls. So if you wouldn't mind taking a second and answering, they should be starting momentarily. And the results of that poll will be shown to all the attendees. So hopefully you find this information helpful. Okay, looks like our first poll is now up. And this is just simply describing your position, so what you do. Great. Looks like the first poll is finished now, and lots of developers out there, so great news. I think you'll really enjoy what we have put together for you here. So next poll should be up here momentarily. This one is really getting at what stage you at in your game's development. So if you wouldn't mind clicking on one of those. And looks like the vast majority are in development, so almost 80%. Great. And I think we have one more poll. And this one is your current hosting situation. So are you already in the cloud? You're using Amazon? Are you with a managed hosting provider? If you wouldn't mind just clicking on one of those. Great, so pretty even split. Interesting. Okay. Well, thanks everyone. I think that concludes the polls. So why don't we jump in? Again, thanks for joining everyone. My name is Josh Frazier. I'm the Vice President of Business Development here at RightScale. And I'm pleased to be joined this morning by Jeff Barr. He's the Senior Web Services Evangelist with Amazon Web Services, and also Seth Gerson, who's the CEO and founder of AltEgo. On the Q&A logs, we have Ryan McGinnis. So as usual, we're going to be taking questions throughout the webinar, so feel free at any time to ask a question. Just use the chat window within the GoToWebinar viewer, and we'll be answering those both live as well as through the Q&A log. If for some reason we're not able to get to your question, we make a habit of following up with each and every question post-webinar. So the agenda today, we're going to quickly go through social gaming in the cloud, and it's great to have Seth joining us this morning because Seth's going to take us through actually two different use cases of his own experiences of deploying two different games in the cloud. So we're going to start off talking a little bit about his experiences with Watchmen, and then we'll take a look underneath the hood, so specifically how RightScale and Amazon have partnered up here to deliver what is really now the reference standard in social gaming in the cloud. We'll finish up with another example from Seth on AltEgo, so he'll take you through what that's all about. And as usual, we always like to show folks an actual demonstration so you can see the product live, so we'll spend a little bit of time in the dashboard. As a reminder, all of our webinars are available, both audio and video, so this is a recorded session. Usually it takes about a day, and that can be found at rightscale.com/webinars. So with that, I'm going to turn it over to Seth. And Seth, why don't you talk a little bit about Watchmen, kind of what you experienced when you launched that?
Sure. When we started off, we had about 6 months to develop a game. And when you looked at the specs of the device that we were aiming for, there was really no other way to do it. It was an MMO, and it was targeted at the iPhone. And when we were looking out at just building the, if we hit the next slide, please. When we were looking out and we were just targeting infrastructure, if we were going to buy that metal from Dell, it was going to set us back about $1.5 million day one. And instead we paid about $5,000 a month. But the real key is just when things happen, they happen really, really fast on apps, on social games. And so in the first 25 days, we had a total of 21 million GET requests. Out of those, 500,000 came from Hong Kong and Tokyo, and the game wasn't even for sale there. And the thing I'd point out also is 50,000 of those were render requests, and those render requests basically seeded those 21 million total GET requests. We hosted at the same time, using the same infrastructure and scaling, 250,000 battles, which is basically people one-on-one linking up and fighting each other. If we could hit the next slide, please.
Great. So yeah, thanks, Seth. So I think the key is, and we see this quite a bit with social games and online gaming in general, which is kind of the challenges of success, if you will. And what you experience with Watchmen, that's actually pretty typical for those average performers. We see increases of around 50% week over week. You saw some pretty extreme examples in the quotes you just mentioned there, but also we've seen things ranging from 0 to 10 million daily active users in the first 6 weeks, and even 100x server growth in less than 4 days. So I think the point here, just to reiterate Seth's comment, is when things happen in this new world we're all living in, Facebook and mobile devices, things happen really, really fast. Even with the best intentions and unlimited budgets, it's impossible to predict what kind of load your game will be under when it hits. But all this said, you still have a key need to maintain control and transparency into what you're doing. So it's really for those reasons that Amazon and RightScale have partnered up to create what is more and more becoming the reference standard for social games. It is a best-of-breed set of technologies from Amazon Web Services, and Jeff Barr is going to take you into a little bit more detail about what those are all about, combined with the automation and the configuration management and control solutions that RightScale brings to the table. To give you an example of what this package has been able to deliver, these were stats pulled last night from App Data. The red arrows indicate the actual games, and then on the right-hand column are the providers themselves that are currently utilizing the RightScale and Amazon suite of services around social games. So lots and lots of experience around the good, the bad, and the ugly of deploying social games in the cloud. And what we hope you get out of the webinar today is just a little bit of a sneak peek on how these top providers are succeeding in the cloud using RightScale and Amazon today. So with that, I wanted to introduce Jeff Barr, and Jeff's going to take us into some of the depths of what Amazon Web Services is all about. Jeff?
Okay, thanks, Josh, and thank you all for coming. So let's take a little peek behind the scenes and see what kind of infrastructure actually powers these games to enable them to run so efficiently and to scale so quickly. So I'm part of a team called AWS, or Amazon Web Services, and since about 2006, we've been making IT infrastructure available to organizations and businesses of all sizes, basically very flexible, scalable, and secure infrastructure. It also happens to be quite cost-effective. And the real fundamental idea is that compute power, storage, messaging, database, and so forth are all available to you as a developer on demand, and you need only pay for what you use. So you heard Seth talking about his estimate of $1.5 million of Dell hardware versus a $5,000 per month IT bill. That's kind of an example of the flexibility and of the cost savings. And one thing that he didn't even mention is the fact that you get effectively a linear relationship between the amount of usage of your game and your costs. You don't have this very, very large fixed cost that you have to worry about regardless of the success level of your game. So AWS is basically this infrastructure that you can use to host your game. And let's move ahead to the next slide. And let's take a look at this whole idea of cloud computing and kind of where it came from in regard to some earlier industry trends. Things like software as a service that give you the ability to host in the cloud basically any kind of application. You can literally, on the cloud, you can start in at the infrastructure level, choose your operating system, and load the application stack of your choice. And any programming language, middleware, development tools, and so forth all will run in the cloud. Grid computing gave us this idea that you could basically take advantage of thousands and thousands of network servers and be able to use them and process with them as a group to give you access to just as much compute power as you might need. Virtualization, the idea that you can create these machine images, run them virtually on top of real hardware, and then allocate, use, and then terminate these virtual machines as your needs change. And needs might change on an hour-by-hour basis. You can allocate servers, have them up and running in a matter of minutes, sustain any surges in demand. If all your users go to sleep or go off to do something else, you can scale down just as quickly. And then the last point, service-oriented architectures. Sometimes people miss this part about the cloud, and I think it's probably the most important one of all. The idea here is that your infrastructure is programmable. So instead of having to cut a ticket or call your systems administrator or call your hosting provider and say, I need more servers, I need more bandwidth, I need more storage. Every aspect of that resource allocation, control, and ultimately freeing up as well is all controlled programmatically. So getting new servers, a simple matter of making a call that's known as run instances to the cloud to allocate additional servers. So each different aspect of resource allocation, enumeration, and use is all controlled with code. And finally, let's just kind of take a look at a quick layer diagram. Now, we don't have time to go into all the details here, but I just did want to give you an idea of the various parts and components of AWS. At the bottom, we have common facilities for metering and billing to track your usage and then charge you each month based on your use. Identity and access management to let you create user accounts to give you very fine-grained control of access. And then a number of low-level infrastructure facilities for things like compute, storage, and database, the Elastic Compute Cloud to give you virtual servers on demand, augmented by Elastic Load Balancing and auto-scaling, the simple storage service to let you store objects in the cloud, multiple different database offerings, including the Relational Database Service, or RDS, which is a hosted form of MySQL, Amazon SimpleDB for NoSQL style access, and then the ability to run third-party databases. And then, as you can see from this diagram, a number of even higher-level services for parallel processing, content delivery, messaging, payments, on-demand workforce, and then monitoring, development tools, consoles, and the like, to give you a very, very flexible, very powerful platform. You can choose to use as much of this or as little of this as you need for any particular style platform. One quick note on the Elastic Compute Cloud. Just yesterday, we rolled out a really powerful addition called the Cluster GPU instance, and we now make available to you on an hourly basis very, very high-end machines with a pair of NVIDIA Fermi cards inside. So if you need to do GPU-style rendering on the server, you now have access to those machines on an hour-by-hour basis. So kind of summarizing some of the advantages of the AWS cloud, you no longer have to worry about the heavy lifting. You've got access to our own massive data centers. You've got the flexibility that your own business demands. As your game scales up, you can get the resources you need as quickly as you need them. And you use, and more importantly, pay for only the capacity that you need when you need it. Your costs are going to be lower. You're not going to have to make that $1.5 million upfront capital expenditure to get hardware that might choose to be too much or too little for your needs. The hourly rates are very, very modest, and you'll find that your ongoing operational expenses are going to be lower than many of the alternatives. And it is truly a pay-as-you-go utility-based model. So you can go to our website. All the pricing is on there for servers by the hour, data by the gigabyte, bandwidth by the gigabyte, and so forth. And you're going to be able to get your game to market as quickly as possible. You're not going to have to worry about data centers and hosting and routers and racks and switches and hubs and power and cooling. You focus on what you really, really enjoy doing is building and making your game successful. You can pilot and test games really quickly without having to gear up in case you don't have it just right. And you can focus on your business.
Great, thanks, Jeff. No, appreciate the overview. So where does RightScale fit in all this? So RightScale is a cloud management system, and we sit in between the applications you want to run and the resource pools you want to run them on. It's specifically designed around being an open platform and focused on all aspects of the lifecycle management of the infrastructure resources that are necessary to develop, deploy, and maintain your application. As a general strategy and product rule of thumb, we look to incorporate all the feature extensions that Amazon delivers, and they do deliver quite a few, so there's a lot of availability to take advantage of those within RightScale. But then layer on top of that some core features around helping developers and any company get up and running and take advantage of these resources very quickly. We'll talk a little bit about how we do that. Secondly is a full suite of automation, not just about auto-scaling, but remediation around your environment based on any set of rules that are based on any metric that you're monitoring. So basically reducing the overhead that system administrators will otherwise have to take on manually. Next, we provide a whole suite of control procedures, basically what you'd expect in a traditional data center management environment, but applied towards the cloud. So things like user policies, compliance tools, access, cost accounting. And then finally is this notion of portability. And it's important to note that portability actually starts with the ability to architect across multiple regions within Amazon. These are individual data centers that are located in specific geolocations throughout the world, each of which has their own libraries that they maintain, and in some cases, different features that are available. So RightScale starts with making it very easy to take advantage of more than one Amazon region to create various different high availability and disaster recovery type scenarios. We've been at this almost since day one. So we just, both of us just had our 4-year anniversary, Amazon in August of 2006 with EC2 and RightScale September of 2006. So quite a bit of experience in deploying and managing all different types of customers in the Amazon cloud. We're at about 1.7 million servers and counting. And we're proud to say that we're behind the largest production deployments on Amazon to date. So what you see here is just a sample of some of our customers. And it's really meant to show you more to demonstrate the broad range of customer types that are running production deployments in the cloud today. And then specifically within gaming, customers such as CrowdStar, Zynga, Electronic Arts, Playdom are all taking advantage of the RightScale platform on Amazon Web Services. So a couple key concepts before we turn it back over to Seth to take us through the alt-ego use case. RightScale takes a little bit of a different methodology when deploying and managing in the cloud, and it's something that we refer to as server templates. What server templates are a way to dynamically configure instances at boot time and do further runtime configuration through remedial actions that the RightScale platform will take on your behalf. The net result of this is you do not have to maintain images. So you're not dealing with static images, which become very unruly once you try to move things around, once you deal with any sort of scaling environments. Just dealing with static assets becomes very, very difficult, and the overhead is very high. So RightScale server templates abstract away from the image as much as possible, typically leaving just the base operating system and the RightScale agents, and then the remainder of the configuration is done dynamically by the platform. The next key area are what we call deployments, and think of those as entire systems that are managed as a single unit. So most games, when they go into production, are not just looking for a single server. You have multiple servers, multiple tiers, various different security, storage procedures, networking. All of those components can be combined into a system or a RightScale deployment that can be managed as a single unit on our platform. And then finally, RightScale macros. And macros are bundled systems that become easy to publish into new environments. And we see this quite a bit in the gaming community as you roll out one game after the next or leverage various different relationships between publishers and independent studios. So with that, I want to turn it back over to Seth, and what Seth's going to do is actually take you through a real case study around a new service they have called alt-ego that leverages RightScale and Amazon in this server template approach. So Seth, take it away.
Thank you. So for the past 2 years, we've been developing this platform called alt-ego, and what it allows you to do is take one avatar onto any consumer electronics device or into any blog, Google TV, etc., and any game as well, obviously. So if we go to the next slide, we've signed a bunch of partners and developers we're starting to give access to now. We'll be announcing soon some of the largest players in the social gaming space as well jumping on that we've already signed up. And what we're really doing is redefining the way people think about what their avatar is and how they can use it. And especially as they start to move that avatar from game to game and to bring those digital goods and have to show consumers that digital goods have a higher intrinsic value, we give them that value prop and the ability to do it. And as we're entering a new era of digital payments, one way to look at avatars are they are really our credit cards of the future. And so on the horizon, we really look at avatars as the tip of the spear for payment devices. And really the key is to enable the developer to make money. Because at the end of the day, if the developer doesn't make money, they don't stay in business. So for developers, we save them time and money, and we also, most importantly, give them users with the ability to pay. And in building out this system, we had to do something that was incredibly scalable. Some of the deals we signed over the next couple of months will be putting in excess of over 50 million eyeballs and users into Altigo. So we had to have something that we knew would scale very well. And we're very confident in what we've been doing with AWS and with RightScale that we have that sort of scaling capacity. So in being the glue that binds the consumer between the game and the different devices, we have to enable them to take all their clothing with them. And doing that requires being able to quickly scale in different availability zones, being able to transport those goods, and then to be able to have microtransactions around that goods no matter what the experience is. So next slide. Excellent. So what we needed was the ability to reduce the complexity of deploying in the cloud. This would also reduce our cost of human capital. We also needed a painless way to clone servers and environments. This is really important, and using RightScale for this was key to us, because one of the things we had to do in testing out Altigo was to test out games. So in being able to very quickly clone servers and environments, it gives you a very fast cycle time and the ability to dev and test. It also gave us an automated way to launch and configure our servers. And one of the most useful things was to have fail-forward analysis on those servers. So so we could basically look in a timeline and see where something went wrong and what we could do about it to improve for the next time. And then the final thing, very important, is a unified interface on multiple clouds, because by having that, it makes it very easy for us to sort of go to from a macro level, to make it very easy for any of our guys to jump on and do whatever's necessary to keep things going. And next slide.
And Seth, out of the gate there, I mean, your customers really are region-specific in a lot of cases, right, in terms of where their gamers are coming on and where they're located?
Yeah, absolutely. So, I mean, they are region-specific, but we even use this when we were looking at testing. I mean, one thing we did is we locked off our servers to the East Coast of the United States, and we started testing with users in Turkey and Malaysia, so we could get a really sort of a worst-case scenario, and that enabled us to sort of see what things look like in a worst-case scenario. And then, once we're running globally, it's much better. One of the interesting things was the Watchmen game. If you just look at that on it in and to itself, we had 500,000 people playing in Hong Kong and Tokyo before the game was even for sale there. So what we got with RightScale was just really, it was super easy to get up and running. So, our systems levels management was multi-tier, and we were using the RightScale deployments, made this very easy as well. It also one of the key things is having fast development and test cycle times, and the ability to reuse templates for different games that you launch, because when you're launching a game, you're going to have your live environment, you're going to have your test environment, you'll probably have a dev environment too. So when you have multiple deployments, being able to just pick a server template and use it multiple times makes things go a lot more quickly. It's more painless, and it makes revisioning much easier as well. And then auto-scaling and configuration obviously are key for everybody, and RightScale makes that really easy. And then, like I said before, the fail-forward strategy really keeps downtime to a minimum, and using a historical downtime really allows us to see what went wrong and where it went wrong, so that we don't repeat the same mistake twice. Hopefully.
Seth, maybe a little bit more detail exactly how you're approaching this fail-forward strategy. What are you leveraging in the system itself?
So I have Susan on the phone, and I think she's the best one to answer that question.
Yeah, sure. What we do with the fail-forward is that when a server goes down, rather than try to diagnose what the problem is right then and there, we clone the server, we start up a new one right away, and we continue moving forward. Then we can actually take the time offline to go back and analyze what happened on that down server.
Great. So this concept of always roll forward, it's an interesting segue into the demo. This is a new paradigm, working within the cloud and dealing with kind of disposable resources, if you will, which is a lot of times, and we highly recommend this, and it's great that Seth was able to bring this up, but instead of stopping what you're doing and doing the troubleshooting, it's going to cost you considerably less money to just continue to move forward. So clone the environment, launch new resources, and then when your cycles permit, go back and then do the troubleshooting on what may have happened. So these resources start as low as 8.5 cents an hour. So it's very, very agile, and it's a very different way of operating and thinking about IT. So it's an important concept to think about here when you're deploying. Great. Well, thanks, Seth. So it sounds like a lot of the familiar themes that we hear quite a bit from game customers, which is, you're global by nature. You're dealing with multiple, in your case, you're dealing with major publishers who demand a high level of performance around uptime, the ability to have high availability architectures to achieve massive scale. And then I'm guessing also you're doing quite a bit of revision, so this dev and test cycle time is also very, very important.
Absolutely.
Great. So with that, let's talk a little bit more in detail now on how this is actually happening. So what we want to show you next is really to capture a bit of the gaming lifecycle curve as we've seen with the customers, like Aldigo, like Zynga, like Playfish that we've worked with for a couple of years now, which is every game pretty much follows this same pattern where you have, concept and development. So it sounds like we have a very developer-centric audience from the poll today. Which is great. I mean, the last thing that you want to have to worry about is infrastructure. But if you're not prepared and not thinking about it, that can torpedo your whole initiative. So the balance becomes, how do we take that off the equation but give you tools that can enable you to succeed when you're ready to move into production? The next phase around production and growth, well, that's all the success disasters or the rapidly changing environment that comes with success that you heard us open up with during this webinar. If your game's a hit, things will happen at a level that may not have been even contemplated, and they will happen at a pace and a rate of change that is almost unimaginable. So just think about for a second, your game takes off. How would you change your environment, and how would you handle growth that's 100x in 3 days? And we've seen that type of growth with customers that we've already deployed. And then maturity and decline gets into, all right, so there's a real business behind this now. So all the things that may not be as sexy to talk about or think about, but are crucially important when you're operating your game. So who has access to what from a user standpoint? What permissions are they set up with? What are the games costing? So to be able to assign specific accounting and metering to each game and stream that information back into the appropriate groups internally. Kind of everything that goes into running an actual production deployment and having to worry about a P&L behind it. And then last but not least is the end of life. A lot of these architectures are constantly being refined, and what we see our customers do quite a bit is take all the learnings from one game that was successful and apply those learnings to the next game. And I'll show you how that's done within the system, but there are easy ways that you can do rapid iterations here and take best practices and then codify them to other areas of your organization. So let's touch upon a few things. The first is around rapid cycle time when it comes to development and test. So I don't have to tell this audience what the concerns are here. You want access to resources quickly. You need to make changes quickly. You don't want to have to deal with procurement or configuration timelines. What you're able to do within RightScale is leverage pre-built systems, right, that support multiple different programming languages that can be spun up or spun down on demand. And again, this is more than just launching an instance. This is a system. So this is a system that is production ready so that when you finish your tweaks with a few adjustments, you can roll into production. The second component here is around taking these systems and then making them accessible to multiple independent environments. And again, we see this as being very common. We work with a lot of independent developer studios. We also work with major publishers, and we work with divisions of publishers that function as game developers. And what happens here is oftentimes IT is used by the publisher as potentially a leverage point. Distribution in online gaming has a lot to do with where the infrastructure resources are. So instead of sacrificing some of your margins when you're negotiating that deal with the publishers, you, through using RightScale in the cloud, can have access to all of the global IT resources that Amazon offers. And then using the publishing capabilities within RightScale, you can take one configuration, essentially clone that, and then publish it out to the next studio, but have complete isolation and control about who has access to what. So it's a very easy way for developers or publishers to create and maintain environments, but extend those environments out to third parties or out to others in their organization, but maintain control. And then last but not least, before we jump into the demonstration here, are, well, what happens in growth situations? So here is where, RightScale perhaps shines brightest, which is all around the automation that's required when your game moves into production. So certainly auto-scaling is a very important piece to this equation. We're always careful to point out, though, auto-scaling really includes two key components. There's the auto-launching component. That's simply, the ability to go grab and launch a resource based on some metric that you set. But the considerably more difficult piece is how do you auto-configure that resource and bring it into a production system in context. And what we mean by that is, how do you launch a series of application servers, for example, and have them automatically, without the need for system administrators to go in and configure them, check into a load balance rotation, write to a database, have the appropriate keys to write to that database, kind of everything and anything that goes into configuring that server to bring it into a productive state as part of a system is the other half of RightScale's automation when it comes to auto-scaling. And it's crucially important when you're dealing with any sort of extreme scaling event. You just simply, humans cannot configure servers fast enough to deliver what's needed when things go viral. So here's an example of a typical multi-tier, multi-server architecture that we see commonly used in the gaming space that includes redundant front ends and app servers as part of a fixed cluster, a caching tier, and Memcached is very popular, and then a master and multi-slave configurations deployed across multiple Amazon availability zones. So there's certainly variances, but this represents a fairly typical architecture for setting up a scalable environment. And so with that, I want to jump now into the RightScale management system itself and show you a few of these concepts that we've been talking about. The first is we're going to show you how you can leverage pre-built systems. And these are systems that have come out of the many, many years of managing cloud-based architectures and extensive knowledge in working with gaming customers. So this would be around development and test. You're working on your game. Second, we'll see how you re-architect that system to move into production and get it ready to scale. And then finally, we'll take a look at how you'd fine-tune some of the configurations around the automation and then some of the tracking and control mechanisms. So again, feel free to ask questions at any time. And now let's jump over to the RightScale dashboard. And what you're looking at here is after you've logged in this case, I'm logged in as an administrator, and wanted to call your attention to a few areas initially here. This first area is this notion of accounts. So you can see here there are a whole host of RightScale accounts, each of which represents an isolated environment where your developers or publishers can have access to. Within this isolated environment, you have RightScale deployments. So in this particular account, self-service, you'll notice here that I have a developer sandbox, and then I have pretty much the same architecture that you just saw on the slide. So this is a fixed 4-server cluster that is using PHP app servers, software load balancers from HAProxy, and then a MySQL database. So a fairly typical fixed 4-server cluster. So what I want to start off with is show you how you would leverage these pre-built systems to quickly provision environments within RightScale on AWS during the game development and testing phase. So with that, I'm going to go over to the design section of RightScale and view RightScale macros. And as a refresher, RightScale macros are automated ways to build out systems. So let's just pick a simple example. We'll keep things consistent here. And let's build out this multi-tier LAMP environment. So this is what's already running as a deployment, but let's go ahead and build another one. So I'm going to execute this macro. And what's happening now is RightScale is going to go through a series of instructions around how to create and build this system. It's going to prompt me here as this macro runs. It's going to prompt me here for a few different inputs. What's included within RightScale's macros is the ability to have fixed or dynamic inputs, which are just environment variables, which will get called upon during the boot process when your system is configuring. So in this case, it's just got one input, and it's asking me to select an SSH key. Well, I only have the option of the default. So I'm going to go ahead and select that. And now it's going to ask me for what I want to name this deployment. So let's call this deployment Game Webinar Alt Ego. And click OK. And now this macro is going through its instructions to build out this system. So it'll take just a few seconds. It looks like this executed successfully. And now let's go ahead and click on OK. And if we jump back now to our Deployments tab, you'll notice that this new deployment called Game Webinar Alt Ego has been created. If I click on this, you're going to see it is the exact same fixed 4-server cluster that's currently running. All right, so you notice now in just a few seconds you're able to access a pre-built system, and then by clicking a button and then selecting a few predefined inputs that have been set by the administrator, you have a 4-server cluster that's ready to launch. I can just simply click All Shown and hit Launch, and in a few minutes these resources will be provisioned and configured within Amazon. The next key component here is I can now take this environment. So let's say this is the Watchman deployment, and let's say Seth now wants to make this entire architecture available to the Alt Ego team. I can actually go out to macros now, and I can create a new macro. So I can create a new macro off of this deployment. And in this case, we're going to select the one we just created, and I can go ahead and click Create. And then once I've created this macro, I have the ability to actually publish this to another environment. So I can publish this. In this case, I'm going to share it privately. It's going to first ask me to agree to a basic EULA. And if I wanted to share this now, I can do, let's do the Alt Ego team. And we don't need a logo. And I can go ahead and click on the support information, check with Seth. And I can go ahead and click Share. And what that'll do is that'll make this environment available in any account that I choose to share it with based on the next sharing group selection. So we're not going to go through this process in the interest of time, but hopefully you see the concept here, which is you can easily provision an environment, take that environment, and then publish it out to another account within RightScale that may be an entirely different project team within your organization, and it also may be an entirely separate company. So it gives developers and studios a way to extend environments to publishers and vice versa, but continue to maintain control. So we're jumping to the next demo. We had a question in here around does RightScale support AWS HPC, so high performance computing clusters. So actually, Jeff, you want to say a quick note on what those are first off?
Sure. So we've actually introduced two separate server families or instance types in the cluster side, and these are both intended to be very, very high-powered machines. They have 22, 23 gigabytes of RAM, dual Nehalem processors, nearly 2 terabytes of local disk. They're 64-bit platforms. The basic cluster compute instance runs about around $2 per hour, as does the cluster GPU instance. And the cluster GPU adds dual NVIDIA M2050 GPU boards, giving you a massive amount of processing capability on a by-the-hour basis.
Great. So the answer to the question, does RightScale support it? Yes, absolutely. So you can access these compute clusters via RightScale. And that just reiterates what we talked about earlier, which is as a general policy, RightScale looks to support all of the feature extensions and services that Amazon releases. So jumping back to the next concept within the demo here, so I want to now focus on this running deployment. So here we are looking at a multi-tier environment. So we have redundant front ends. These are PHP app servers. We have a database and a load balance server. So now what we're going to show here is how you would do system cloning and re-architect this environment to get it ready to roll into production. So RightScale has a feature up here called Clone. So I'm going to go ahead and click on this Clone button. And now I'm going to rename this deployment. So let's call this Alt Ego Production. And now if we jump back here to the RightScale dashboard, you'll notice that, let's give this a chance to refresh here, you'll notice that this deployment now has been renamed and it's not running. So when you clone an environment, what you're basically doing is you're taking a carbon copy of not only the specific instances, but also all of the configuration that is part of that system. So storage configurations around snapshots and backups, specific networking and security configurations like Amazon security groups. So everything that goes into that system is configured, is essentially a snapshot that you can configure and quickly clone so that you can make changes. So let's jump in now and take a look at this gaming webinar Alt Ego. And now what we want to do is we want to get this ready to roll into production. So in that case, we want to make sure that the automation is set up and that it's ready to scale. So here we're going to add an array. So an array is essentially a cluster of homogeneous servers that will grow and shrink horizontally based on various different metrics that you set. So here I have the choice of where I want to add this array. I can add as many arrays to this deployment as I want, and we see this quite a bit, and Seth alluded to this earlier, which is these games are global already. So having the ability to set up configurations in this case, 4 different geolocations that Amazon offers, Southeast Asia and Singapore, Europe and Ireland, Virginia on US East, and then California on US West, gives you a lot of flexibility around performance and maintaining optimal cost controls, as your game traffic comes and goes during the day. So in this case, let's add it to the US East. And let's call this array 1 East. And we're going to set this up as an alert-based array. And we're going to add it to the game webinar Alt Ego multi-tier deployment. Just like any other server within Amazon, okay, servers that are part of an array are configured dynamically using a server template. So I'm going to select the appropriate server template for this deployment. In this case, it's the PHP version 10 template, and it's published by RightScale. You as a customer can, of course, write your own templates from scratch. We have a vast library and ecosystem of ISV partners that you're free to leverage. Or you can take our templates and modify them as you see fit. So again, the platform is very open. This template is leveraging a multi-cloud AMI. Okay, so you're not having to deal with maintaining and publishing an AMI. RightScale is doing that for you. The instance type is dynamic based on what's set within that server template. I'm going to select the default SSH key and the default security group and go ahead and click Save. And now what you'll see here is this array has been added now. If we go back to this deployment, this array has been added to this game webinar Alt Ego multi-tier deployment. So you now see this fixed 4-server cluster, and we have array 1 in the east. So what we've basically done is we've set up this environment here where you have a fixed 4-server cluster, but then you have an array of application servers that are set to scale. So it looks like we got a couple more questions, so let's pause here and take a few of these. The next one is around, so similar kind of feature extensions here from Amazon. Can I use reserved instances? So absolutely, you can use reserved instances, and there was also a question around can I use EBS or boot from EBS-based instances. So yes and yes on both. And again, a general rule of thumb here, RightScale supports everything that Amazon does. Some of you may not be familiar with reserve instances or spot pricing. Maybe Jeff, if you wouldn't mind a few things on that.
Sure. So there's actually 3 separate ways that you can arrange to use EC2. The most straightforward one is called on-demand pricing. And so with on-demand pricing, you simply consume EC2 instances on a by-the-hour basis, and you pay the list prices on the website. That's great if you have unpredictable needs, highly variable needs. If you have the ability to predict for an extended period, let's say a 1 to a 3 or a 3-year period, kind of a baseline level of EC2 usage, we have a model called reserve instances. So with the reserve instances, you make a payment up front to reserve capacity for a 1 or a 3-year period. And then in exchange for that commitment, you get a much lower hourly rate when you actually do go ahead and use those instances. So for steady state usage, reserve instances are a really good way to save money. Now the third way to do it is called the spot market. And with the spot market, this is when you have background processing. What you do is you submit a bid and you say, in this particular AWS region, I'd like to run this machine image, and I'm willing to pay up to this amount of money per hour to do it. So based on competition for the resources, we'll select a set of bids, and we'll launch those machine images, and we'll run them as long as they're the leading bids for the resource usage. So there's actually third-party sites that are now devoted to tracking the long-term history of the EC2 spot market. So you can see the variety of pricing and how that changes from kind of hourly within the course of a day, and different pricing on weekends, and different pricing from region to region as demand changes.
Great, thanks, Jeff. So a lot of ability here to optimize your spend within the cloud, and again, all these tools can be configured certainly within RightScale. Keep the questions coming, and I forgot to mention early on, we'll stick around past the hour. That's also something that we like to do here. As long as questions are coming in, we're more than happy to stick around and answer them live here. So the next question here, and this is a great segue into the next part of the demo here, which is what thresholds trigger the array? So essentially, what are you using to base the automation on, and how does that all work? So within RightScale, you're monitoring a whole host of system-level metrics. So everything ranging from disk I/O, requests, load, schedule, things of that nature. Any metric that you're monitoring within RightScale can lead to an alert and an escalation. And an escalation within RightScale is a remedial action that the platform will take on your behalf. So let's look at this array here. So we're back in this array we just created, Array 1 East. And I'll take you through some of the common configurations that we see used in particular with gaming customers. So the first is around this allocation policy. You have the flexibility to determine where you want to pull resources from. Okay, so this is not just an ad hoc round robin. So if you want to place these resources in a specific availability zone or in a specific region of Amazon, you have the flexibility to control that. Second is you can set the limits around your array size. So in this case, this array is set to grow to no more than 20 servers. And we see this used quite a bit for performance reasons. We see this used quite a bit for kind of growing in different regions within Amazon. We see this used quite a bit around cost control. So you have the flexibility to put limits. The next area is around all the options. RightScale takes a unique approach here. It's a very democratic approach where we have this notion of a voting process and a decision threshold. And right now you can see this is set at a simple majority. What this means is that any action that RightScale is about to take, in this case, let's say it's growing your application array, a majority of those servers, all of the app servers, a majority will have to agree that they too are experiencing the same metric that you're set to run this automation off of. I can go in here and change this to be whatever I want, but this is an important fail-safe because it prevents any one misbehaving server from hijacking your deployment. So if I wanted to bring this down and say, you know what, I only need a third of these servers in the array to agree, I can change that. You also have the ability to change your sizing up and down. And again, very common in the gaming space. If you want to take a more conservative approach towards scaling up, I can grow by 5 servers, and then every time I decrease, I can take away 2. So this just gives you a little bit greater ceiling just in case that growth curve continues. So all of this is very configurable. Finally, I have the ability to set a simple schedule, so time of day or day of the week. You know, even with all the automation that RightScale provides and all of the vast resources on demand from Amazon, if you know you're going to launch your game at a specific time of day and a specific day of the week, you might as well set a provisioning schedule so that you have extra resources on hand. That's the beauty of this pay-as-you-go model. You can over-provision, and it literally will cost you a few bucks often at times, and then pull those resources away when they're no longer needed. So next question we'll tackle here, it looks like we have a question around databases. So specifically, databases seem to be the trickiest part to figure out. That's a fair statement. It doesn't seem to be as easy as adding more front-end servers and load balancing. Any tips for effective ways to scale your database here? So we've seen this quite a bit. There's really 3 approaches that we see used heavily with our customers and specifically within gaming. The first is around vertically scaling your database. And here's something where both the server templates deliver a lot of value around the dynamic configuration, but also the various different instance types available from Amazon. And maybe, Jeff, if you wouldn't mind just kind of highlighting the range of instances from small to quad XL, it's pretty amazing what's available.
Okay, so we actually currently have 11 different EC2 instance types. The smallest one is called a micro, and you can get those for 2 cents an hour, and those have about 700 megabytes of RAM. And from there, we have several different families of instances, both 32 and 64-bit. But the largest memory one is called a quadruple extra large, which actually has 68 gigabytes of memory and 16 processing cores. And so quite a wide variety of instance types. And as I mentioned before, the cluster and the cluster GPU instance types as well.
So the vertical scaling, here's what happens on that. Remember now, server templates are abstracting away the definition of that server from the underlying instance. So you're not bundling static AMIs. Instead, everything is defined at this server template level. And then what happens here is you have the ability to have the same server template take advantage of more than one instance. So if you need to vertically scale, you have the opportunity of that same server template launching a large, then an extra large, then a double X, and then a quad XL. So very, very flexible. So that's around vertical scaling. Server templates and the various instance sizes make it very easy. We see a lot of horizontal scaling, so both using NoSQL solutions, and also we see sharding be commonly used. So there are a variety of different ways that you can set this up. And what I'd suggest, just in the interest of time, is feel free to shoot us an email, and we'd be happy to share with you some best practice architectures as well as introduce you to some best-of-breed technologies that we've seen be deployed on RightScale and Amazon from companies such as Zynga. So both sharding and using NoSQL solutions are very, very common. And I have to apologize. It looks like my screen is frozen here. So this is unfortunate. But that was bringing us to the end of the demonstration anyway. So maybe now I'll turn it back over to you, Seth. And unfortunately, I'm unable to pull up the slides. So again, our apologies here for the technical difficulties. But Seth, so what was the results with AltEgo when you launched it in the cloud on RightScale?
I mean, we scaled up to 200,000 people in no time just as a test, and we signed some really, really big deals with some of the big guys. So that's going to be going out over the next couple of months, and we'll see millions of people jumping on. But I think the key thing using AWS and using RightScale, and the reason we built this system is our background is all from console gaming. And when we first started off, and we were in console, our guys here have worked at the biggest publishers, first parties, and actually the biggest games that were on the that were in this space. And when we moved into social, what we did is we said we need to develop something that our friends can use and really any developer can get their hands on. And there were a couple key things there. So the first thing is when you're a developer, it is hard enough to make the game and to make the game logic, and you really have to concentrate on making something fun and that's playable, and you need to be able to revision it multiple times a day so that you can see how users touch your games. You don't develop it in the way that you used to make console games. So if you go and you use AWS and you use RightScale, your infrastructure needs are taken care of. You don't have to worry about that. It's one less thing you can worry about. It's completely worth it. The other thing is worrying about locations and a fixed infrastructure. It's too difficult to worry about. And then also there are a lot of other things that come into making games, because games now are very social. When they happen very quickly. So you really need to get your sort of handle on the analytics. How do you manage your currency? What are your what's microtransactional in your game? How do you manage those microtransactional goods? How do you handle your payment systems? How do you handle your offers? And then also, you need to give users, and this is the key thing that we do with the Alt-Ego package that we've put together. When you combine that with RightScale and AWS, you get everything that you need to get up and going. You can then focus on your game logic, making your game fun, and making it addictive and something that brings a smile to the user's faces, and that's key. And then the final thing that we give that is critical for the developer is we give you not only users, but users that we know pay. Because when you look at when people come into these games, you get a lot of people that come in. But really there's a small percentage, and that percentage that pays, they pay you thousands of dollars a week. And that's the critical thing, because when you have users that pay thousands of dollars a week, those are the ones who really are able to foot the bill for the entire game. And those are the ones that you have to know what they like, you have to understand what their mindset is, and you have to be able to give them the service that they expect. And games have really changed now. Games are a service. They're no longer something that you make in a box and put out there and hope people like. You have to change them, and you have to tweak them, and you have to do a lot of testing around them to be able to enable the user to have that kind of experience.
Great. Thanks, Seth. And we've switched over screens here. So we're getting towards the top of the hour. We'll stay on, so keep the questions coming. And again, the webinar will be available both audio and video in about a day. But just to finish up here, one of the things we've also done here is we've actually created a specific edition of RightScale in conjunction with AWS called the Social Gaming Edition. And this is bundling together a lot of the best practices that you heard us talk about today. And this is what Seth and our friends over at Alt-Ego are taking advantage of. So you get the benefits of kind of the tried and true and well-tested best practices here. So with that, there's several reference materials that we have available. So why don't we advance here to the next slide. And we highly encourage you to just try something out. So the nice thing about the cloud is the level of commitment, both financially and time-wise, is mind-bogglingly small. So go ahead and get an Amazon account if you don't already have one. It looked like about 40% or so already do. All you need is an email address and a credit card. There's no commitment to spend anything, and you can get an Amazon account. RightScale has a free edition as well. It's unlimited usage free edition. All you need is a set of Amazon credentials. And then if you'd like to take a look at the Alt-Ego SDK, that's available today as well, and just simply email that address. So there's really no reason not to try things out and learn for yourself what some of the advantages are of taking advantage of cloud computing here. And again, you can check out this archive. We also have several other gaming webinars that have been run in the past. But let's tackle a few more questions here, and again, feel free to jump in with any additional ones. So this next one is around, looks like another database question. So specifically, I have a setup with a MySQL master slave. How do I automate switching in kind of dealing with failure scenarios and promotions? So thinking back to that architecture diagram we showed you, we recommend as a best practice approach here for gaming customers is to run a master and then a multi-slave configuration across at least 2 Amazon availability zones. What happens within the server templates, again, these server templates are dynamically configuring and doing runtime configuration of these instances on Amazon, and these server templates are also members of a system, so they're members of a deployment. So in the database example, part of the configuration logic within the templates is how to deal with failover procedures and various different replication and snapshot schedules. So in the case of the MySQL multi-slave, if your master fails, RightScale has been automating everything from snapshots of your Elastic Block Store, replication schedules, master to slave, and then it also can handle the reinstantiation of new slaves when that slave gets promoted to master. So master fails, slave gets promoted. RightScale will automatically provision additional slave instances, restore those slaves from the latest snapshot of EBS. In just a few minutes, you're up and running again. And it actually is a great and very common example of failing forward, as Seth mentioned. So we're not suggesting don't ever take a DBA and go back and troubleshoot, but continue to move forward, and when your timeline allows you, and when you have a cycle, go back and figure out what went wrong.
Yeah. Also, depending on your needs, you might want to take a look at the Amazon Relational Database Service as well, because it offers an automatic redundancy between a pair of availability zones and lets you easily create read replicas. So I've got a couple questions here I'd like to address. So one of them was, how does AWS make sure that performance doesn't go down over Christmas? So I think this goes back to a very common AWS myth that I sure wish I'd squashed years and years ago. That myth being that AWS was once all about excess capacity on our part. AWS, as far as I can remember, and I've been here for over 8 years, has always been about making really, really high-powered infrastructure available to developers, and that's always been our focus. And so there's effectively no sharing of resources between AWS and the retail site, where they're not fighting for resources. And actually, a couple years ago, we released a chart that showed the relative bandwidth consumption of the retail site and of our AWS customers. And I'm thinking that chart dates back to somewhere mid-2008, if memory serves me right. And at that point, the bandwidth used by AWS customers had already exceeded that consumed by the retail site, and it's only continued to grow in the time since then. We also do publish an SLA, a service level agreement for EC2 to guarantee a certain amount of availability. And also, it's really important to note that when you allocate EC2 instances, you are getting an allocation of a certain amount of CPU power, a certain amount of memory, a certain amount of disk space, and so forth. So it's not like we're giving you any kind of leftovers. You're allocating and have full access to a certain amount of particular resources.
Great, thanks, Jeff. Yeah, so having worked this long with Amazon, we can certainly attest firsthand that the scale in which Amazon is operating at far exceeds anything that anyone in this audience has probably seen. So we're talking about massive, massive deployments. Think back to that slide I showed you from appdata.com and the customers that are currently deployed on Amazon through RightScale. It is pretty extraordinary. So let's go to the next question. So this one's on pricing model. So specifically explain RightScale's pricing model. So RightScale is delivered as a software as a service. Think Salesforce, so very similar pricing model. There's a base subscription fee that customers pay us. That gets them access to a specific feature configuration. And then from there, the pricing model is similar to Amazon's. It's based on how much you consume. So there are optional services and extra support plans that customers can choose to buy if they wish. But in general, it's a utility-based pricing model with a floor. Next question is on how do I deploy a new version of my game in my cluster, so in the RightScale deployment. Server templates include multiple inputs, as I mentioned earlier. And those inputs can be common environment variables. They can also be inputs that would point to a specific repository for your application code. So, things like Subversion or Git, it's up to you. That's where your application code would be stored. And then when that server goes through its boot sequence, you have the ability to set in what order essentially the configuration scripts are running. And then using the RightScale inputs, you can easily grab your application code and install that on the server when appropriate. So think abstraction, so not only away from the Amazon underlying instance, but also a component-driven architecture where you can separate common procedures that may be shared amongst multiple different servers and systems, but also separate things like your application code from the cluster you want to deploy it in. Next question is around cost controls and what kind of cost controls does RightScale have. So Amazon makes available a whole host of metering information through their API, and that's all available within the RightScale dashboard. So you get visibility into the current consumption on a per hour and month-to-date basis, and also their extrapolations on a kind of what to expect this month, and then what your prior month was. Jeff?
Okay, I have a question here about RDS and on-demand scalability. So the question is, how does RDS handle on-demand scalability requests with consistency guarantees? If a certain table row becomes a hotspot, what would RDS do? So RDS is simply a managed hosted version of MySQL. So it's not going to do anything in that situation that MySQL itself wouldn't do. We give you a nicely pre-tuned, pre-configured MySQL. You do have the ability to control any of the variables that you would like to that do affect buffer sizes and so forth. But we do have the ability for you to create read replicas. We do make the replication delay from the master to the slaves visible in our control panel if you're worried about consistency and in the face of delayed replication. So there's no magic in the sense that we're not going to automatically grow additional databases for you if particular table rows become hotspots, but that's the effective function of the cache of a database itself. That's not something that RDS adds any value to.
Great, thanks, Jeff. Looks like the next question, does the RightScale framework provide an integrated and automated way of using AWS? Well, that's exactly what RightScale is. So certainly AWS extends an API that's publicly available, and they also have many of these features that are available in the API itself. Where RightScale comes in is really managing this complexity at scale. So there's a lot of power within AWS, but what often comes with a fully featured system like that is a level of complexity that many customers simply don't want to allocate the resources towards figuring out. So specifically within the gaming space, RightScale and Amazon together have had extensive experience dealing with all these providers, and it's based on those learnings and based on the fact that RightScale is a platform above the Amazon resources that we're able to configure a lot of these best practice systems that you heard us talk about today. There was a question on, is there a way I can find more information about best practices and customers? Absolutely. So both Amazon and RightScale have a whole host of case studies and testimonials. There's actually a case study available on Zynga's Farmville game and what they went through. So just go to rightscale.com or email us, and we're more than happy to send that to you. It is publicly available. So it's just really interesting. Obviously, Farmville is a great poster child of what scaling could mean, but it gives you some great insight into the challenges that they face and how using Amazon and RightScale they made those challenges. They met those challenges rather. And then Seth, I think the alt-ego case study that you shared at our user group is also going to be made available. Is that right?
Absolutely.
Yeah, so again, we realize this is a new territory for many customers, so I think you'll find Amazon, RightScale, and customers like alt-ego and folks like Seth, it's a very consultative process. So we want to make sure that you're learning, you're adopting best practices, you're really understanding what business agility is all about, and our goal is to help you leverage the resources that are available to you. We have to prove ourselves in Amazon's case every hour, and in RightScale's case every month. So that's how small the charge model's on here. So it's really, really important that we teach customers best practices here. Next question is, can I deploy on running machines? So can I do runtime configuration? Yes, absolutely. And the way this is done is through the operational remediation with server templates and write scripts. So, again, this gets back to a recurring theme here, which is the methodology. Because you're not having to rebundle images and rebundle AMIs, you can do runtime configuration through operational scripts within the RightScale server templates. And you can do that on a single instance, or you can do that on any grouping of instances by deployment, by tag, by server template. So it becomes very, very easy and low overhead to deal with any sort of runtime remediation. And that actually may be a good segue. Seth, you guys want to comment a little bit? I know you do a lot of rapid provisioning and a lot of revisions to your environment. If you want to share a little color on how you approach that, that may be interesting for the audience.
Thank you. Susan, you want to address that one?
Sure. One of the things that we've done recently is we've started up a game with a really rapid development. And in order to support that, what we did was gave each individual programmer a separate server. If we were managing our own hardware and stuff, that would be entirely impossible. But all we had to do was to clone each one of them. We have a special script that we wrote that configures it, and everybody gets their own server and has their own Facebook page and can operate independently of each other.
That really helps us, because that way what it allows us to do is make a lot as games sort of in the social space, as they're getting more complex and the production values are getting much higher. What it allows us to do is do a really sort of massively parallel production cycle, so we can get something out and we can also have that quality maintained.
Great, thanks Seth, thanks Susan. So why don't we wrap up now? We'll leave the Q&A log open, so feel free to shoot in any additional questions. And again, this webinar will be available. Give us about a day, and you'll find it at rightscale.com/webinars. Any and all questions, post-webinar, just shoot us an email. We'll be happy to walk you through it, and recommend please check out those case studies, both the ones from AltEgo as well as Zynga. So I want to thank my fellow panelists. So thanks, Jeff, and thanks, Seth, and the rest of the AltEgo team. And thanks to the audience for sticking around and joining us. Hope you all found this useful, and bye for now. We'll see you next time.
Thank you very much.